So now we're going to be using synthetic division to divide polynomials. Synthetic division is another way to divide polynomials instead of using long division. Now it's a lot easier than long division, but we can only use it whenever our divisor is in the form x minus a, where a is going to be a root. Now a can be positive or negative, so this could be a minus or plus sign. So it's very important that you only use synthetic division when your divisor is in the form x minus a, which means anytime your divisor is x squared or x cubed or any other type of term, you cannot use synthetic division. Now, to look at your problem here, to figure out what a is going to be is important. So if you look at x plus 5, the root of x plus 5, we set it equal to 0 and solve, and that's how I find the root. So the root is going to be negative 5. So for this first example here, a would be negative 5. Now for the second example, you can see that there's a coefficient in front of the x, so I can't just simply look at it and do the opposite sign like we did here. This one, you have to set it equal to 0 again and solve, and you're going to get x equals negative 2/3. So that means a is negative 2/3. Which means I could rewrite 3x minus 2 as x plus 2/3 if I wanted to. So it's important to be able to identify a whenever using synthetic division. The process of synthetically dividing can be a little tricky to remember. So the first step is to always have your polynomial in standard form. Now remember, just like with long division, you need to have placeholders whenever you're missing a term. So for example here, we have a cubic, we're missing the quadratic term, linear and constant. So we're going to put in a placeholder where we have our quadratic term. Now the next step is we're going to omit the variables and exponents. So this is what makes synthetic a little bit different. We're only going to be using the coefficients. So looking here, the coefficient of the cubic term is 1. The coefficient of the quadratic term is 0 because we didn't have one. The coefficient of the linear term is negative 57. Notice how you bring the sign. You must carry the sign with it. And then the constant term is 56. So it always needs to be standard form, highest degree to smallest degree. Now the next thing is to figure out what your a is. So you look at your divisor and you try to figure out what is the root. So if I have x minus 7 and I set that equal to 0 and I solve, x equals 7. So a would be 7 for this particular problem. This is the number that will go in our box, and I will explain that in just a second. So here is the steps to synthetically dividing. The first thing you want to do is put your root or your a value in our box. So this is how you set this up. Every single time you do a problem, you draw a little box. You put your root inside the box, your a term, and then you are going to write all the coefficients of the polynomial that is your dividend. Now remember, only coefficients of the variables. And if you are missing a term, you must put the placeholder. This is very important. If you forget your placeholder, the entire question will be wrong. Now the first step, once you have that set up, is to bring down the first coefficient. So I bring down 1. Next step is to multiply whatever your root was, your a, by the number that you just brought down. So 7 times 1 gives me 7, and I put that in the next column. Then I add. So 0 plus 7 leaves me with 7. So from here, we're going to continue the pattern. So we added 0 and 7 to get 7. Then we're going to do 7 times 7, which gives me 49. And then we add those, and we get negative 8. Then we continue again. Negative 8 times 7 gives me negative 56. And then I add 56 to negative 56, and I get 0. Now the next step is to take these abstract numbers and actually relate it to a polynomial that if we divided using long division that we would end up with. Now, the last column here always represents the remainder. So since I have a 0 in this problem, that means I have no remainder. From there, we increase in degree from right to left, which means the next will be the constant term, then the linear term, then the quadratic, and if I had more, it would be cubic, quartic, quintic, and so forth. So these represent the coefficients of those terms. So the last term is always the remainder. This is the coefficient of my constant term, which just means it's my constant term. Then since I have 7, the coefficient of my linear term is positive 7. And then the 1 represents the coefficient of the quadratic term, which is just going to be 1x squared. So if we were to divide these using long division, you would end up with the same quadratic trinomial using long division. So remember, it's always important to kind of go back to what this all means. What this means is when I take x cubed minus 57x plus 56 and I divide it by x minus 7, I get this term. Since I have no remainder, if I were to multiply x minus 7 times x squared plus 7x minus 8, I would get what I originally started with, my original dividend, x cubed minus 57x plus 56. Okay? Now, since I had no remainder, that means that x squared plus 7x minus 8 and x minus 7 are factors of our original dividend. So let's give this another try. So the first thing I need to do is figure out what number goes in my box here. So I look at my divisor. X plus 2, I set it equal to 0. X is going to be negative 2. So negative 2 goes in my box. Then I take a look at my dividend. I'm not missing any placeholders, so I don't need to put any 0 coefficients. So I have 1, negative 14, 51, negative 54. First step is bring down the first term. Multiply these two together, write it underneath the next column, add, multiply negative 2 times negative 16, put that under the next column, add, 83 times negative 2 gives me negative 166. I add those together, I get negative 220. So the last term is always your remainder, then your constant, then your linear, then your quadratic. So my final quotient would be x squared minus 16x plus 83. My remainder is negative 220, so it's negative 220 over my divisor, which was x plus 2, and that would be the final answer. The remainder theorem can be a very helpful theorem. It says that if I have a polynomial p of x and I divide it by the term x minus a, then the remainder is going to be p of a. So let's remember what p of a means. P of a means the value of the function where I replace every x with the value a. So in the last example that we did, we had this polynomial function. We were dividing it by x plus 2. We knew that if we were dividing it by x plus 2, our root was negative 2. So if I want to find p of negative 2, I do my synthetic division, and I end up with the value negative 220 as my remainder. Now, I could have also found that value by simply plugging in negative 2 everywhere I saw an x in the original function. So whether you synthetically divide and look at your remainder, or whether you just take that value and plug it into your function, you will get p of a. Now, p of a is the remainder, which means if I get a remainder of negative 220, I know that x plus 2 is not a factor of this polynomial. If you get 0 when you plug in your root, that means the linear term that represents that root is also a factor of the original function. Go ahead and give these a try and put your answer in your Google form.